So in Cura, there's a couple of things I want to show you first off. Um, so if you go up to your settings, if you go in here, you'll see your printer. You've got the TAS 6 right here. You can add a printer, and you can manage printers. So like, if you want to print your part on a different machine, you can add it in here. Say, I think somebody has their own printer that they're going to use potentially, and we have a couple of other types of printers at the school here. So if you need to add a different one, if it comes down to that, then you can do that in here. I don't think any of the other ones at the school are working. I'm not sure. So we'll look into that. But for now, just stick with the TAS 6 and give me the print times and stuff for that. And so that's basically how you do the different printers. When you put in a part in here, you're gonna see it show up in your printer here, and you can, I think I already went over this, but you can move it, you can rotate it. So you rotate it. This is how you scale it, so you can make it bigger or smaller. Typically, you're not really going to want to do that in here. You're going to want to change it in SolidWorks so you know what your actual dimensions are. But if it's something that you don't really care about the size, you just want to print it, then you can scale it by dragging these different little boxes on the 3 axes here. So yeah, no, it's actually changing the size of it in here. So let's see. So it's going to slice it. It's going to tell you 12 hours and 5 minutes because I just made it really big. So if I shrink it down, you'll see your print time change. So that's how you know it changed size. Now it's 1 hour and 50 minutes. So, and then mirroring, I actually am not really sure what that does. So we're going to leave that alone for now, but I don't think we'll need to use it. That might be, and it might not be doing anything here because this part is pretty much symmetrical. So that's probably why it doesn't appear to be doing anything. I'm not sure what it does for certain, so don't quote me on that, but yeah. And then mesh type, I don't remember this one either. I think that just has to do with like if you're printing something that needs supports, I think, or you can like put something in and print it as a support. So like say you have this part and then you decide I'm going to put a leg over here to hold it up, then like you can say print that part as a support. I'm not really sure, but anyway, those are a couple of things you can do in there. You won't really need most of it, but the rotate and what was the other one? Yeah, so you can scale, rotate, and move. You're mostly just going to use rotate and move in there. So over here you can change these settings. So quality is going to be like the thickness of your layers basically. So like the thicker your layers are, it's going to be like kind of it's like printing to a higher resolution or a lower resolution. So you're going to have like more of a rough part, but it's going to print a lot faster if you do like a lower quality, or lower, like they call it layer height in here. So you can see what it says over here if I hover over it. Exactly. Yeah. So, so like if you're printing um, something with threads, for instance, you probably want to do high quality just because you want it to, you want it to be nice and smooth so that the threads actually work and they all thread together smoothly. Or if you're printing like something very small, you're going to want to do pretty high quality, and it'll make it take a little longer, but if it's a really small part, hopefully that shouldn't matter as much. And you're going to want it to be more precise versus just print quickly. So there was someone who turned in one part that was going to take 8 hours, and I was thinking one thing that you could do in here was play around with those settings a little bit, like try lowering the quality and see how much time it'll save you. You don't want to lower it too much because you want your part to actually work, but there's stuff you can do in here that'll help a lot. Another thing is the shell. So we were just talking about that a little. Wall thickness. So that's like your outer shell of your part. That's the part that you can see. If you make the walls super super thin, it's going to be pretty flimsy. But you might not need it to be super sturdy. So if you need to save a little time, you can make your walls a little bit thinner. And then infill is the sort of structural inside of the part. So if your infill density is 100%, your part is going to be totally solid. It's also going to take a really long time to print. Let's try changing that right here so you can see. So right now we're at 1 hour and 15 minutes. If we change that to 100, yeah. Hmm. Yeah. Yeah. I haven't looked super closely. Actually, hang on one second. Who was that talking just now? Okay. I can't I'm not great at recognizing voices, so let me uh take a look in here real quick. Yeah. Yeah. Okay. And that was one second. That was your week 1 part or your week 2 part? It was an okay. Yeah. I see you've got 2 in here in your justification. So, yeah. All right. Okay. So yeah, I think instead of changing anything in SolidWorks, once you get this program downloaded, I think what'll help a lot is going in here because you don't need to change like in SolidWorks it's going to be a solid part. You can't really change the infill in the software for when because it's made to design a part, not necessarily to 3D print the part. That's where this comes into play. So once you download the Cura software, go ahead and load your part into your Cura software, and go into these settings and check out the infill density and stuff like that, and you'll be able to make it like less solid if you need to. Um, and that might help. I wouldn't change anything in SolidWorks right off the bat. I would, yeah. Exactly. Yeah, because if you make the change in your part, it's also there's a chance that it'll 3D print weird. Um, like you don't want to try to 3D print a hollow part typically because it's going to print all kinds of supports in there and stuff anyway. And it might not turn out well. So whereas Cura is optimized to kind of make it work for the 3D printer, so it's a better place to do it. Exactly. Yeah. Mhm. Yeah. Yeah. Mhm. Um, it kind of it depends on what it looks like. I think it will work. It'll work fine. You're just gonna have to uh you're gonna have to set it up in the printer right so that it does work, you know. So you can pretty much 3D print anything. Like that's the thing is that it's not will it work, it's how will you make it work. It might you might need to have the 3D printer do additional supports in there if it's not like one solid piece. Because as it's printing, it'll, it comes up from the floor, and like if there's something that's leaning, it might start to tilt over if the printer doesn't print supports for it. But the 3D printer is pretty smart, and it'll kind of do that stuff for you unless you tell it not to in the settings. So, does that I think that just it kind of depends on what you're making. Um, yeah. So, yeah, pretty much. So the 3D printer on I don't remember the exact dimensions. If you look at it, it's in like the Club Mech room next to the offices upstairs. But the 3D printers like if they're like I want to say it's like a foot and a half by a foot and a half is this shape of or is the size of this rectangle. Um, so you've got a good amount of space, and like the thing is, if you try to print anything that takes up that entire space, it's gonna take forever to print. So in general, you're not gonna want to like print huge stuff. You're gonna want to do smaller pieces and like print things in stages, and then put them together afterwards. A lot of the time. So yeah, okay, all right. Yeah, that sounds about right. It might be in here somewhere. I can't remember. I mean, I don't know where to find it, but um, yeah. Like, okay, cool. All right. So just to keep going through this stuff real quick, I'll just run through everything. So if you have any questions, so we talked about infill density. Material is basically you can set your printing temperature, the probe temperature, um, all the different temperatures basically. You don't really want to mess with those because I think they're set up for the printer, so I wouldn't touch that stuff. Unless the printer is like giving you problems, like say it's printing out like super liquidy material and nothing's working, then you can probably turn down the temperature a little, for example. I've never really messed with that stuff, so I wouldn't touch it unless you kind of know what you're doing. But I'm not like the biggest expert on 3D printing out there, so we're gonna kind of figure it out as we go. That's just why I haven't really messed with a lot of those more advanced settings. Um, but then print speed is basically how fast the little extruder lays down the material. And it's kind of, again, it's going to affect your print quality. So, like, you can speed up the print, but it's not going to turn out as good. So the slower it goes, basically, the better your quality is going to be. Um, to a point. If you turn the speed down to like super duper low, it's not going to print right either. So you don't want to really change those too much off of the set parameters. And if you're going to try and change the quality of your print and like change the speed, I would do it up here. Um, so let's see. Travel, I don't really remember what that is about. Uh, it's not really something that you're going to have to mess with. Cooling, there's fans in there to kind of keep the printer cool and keep your part cool while it's printing. Um, you don't need to mess with that much either. Support, this is kind of handy if you're printing something that like needs a lot of supports, or like say let's try rotating this a little bit. Let's say like we're gonna print it on its side and trying to get it to go. But say we're gonna print it like this, so these arms that stick out are gonna need supports, right? So that's where this comes in. And if you have something big like this, where like you don't want these to droop, um, you can kind of turn up your support. So like my support density is at 30% right now. I could make it 50%. Um, and again, your print is going to take longer. That just added about half an hour to our print time. But you know, it's better to have it work the first time and take 3 hours than take 2 hours and not work, and then you have to spend another 3 hours. So it's usually, you know, it is worth it to do it right the first time. If you're not sure, do some investigation. It can probably help a little. um, so I'm not sure what mesh fixes are. That's another one that we probably won't use much. And then special modes and experimental. Again, not really sure. Probably won't use them. So those are pretty much the settings in here. Um, any questions? No? Alright. So, couple small things about the assignments. So, a few of you turned in your justifications. They look good. Your parts look great. I'm excited. I think we can start going ahead with some prints pretty soon. So one thing I wanted to talk about real quick was just in your justification, and Mike, I know you said you didn't have the software yet, so you couldn't, so that's fine this week. But in your justification, make sure that everybody is putting, make sure you're all putting the print time and the amount of material that'll be used. So I kind of asked you to do this in like like your lab write-up format. So you're going to do your introduction, materials, results, and so on. So in the introduction, you know, just state like, this is what I'm printing, this is what the part is. A couple of people too turned in things where I wasn't really sure what the part was. Like they said, this is why I need to print this, but not like this is actually what it's going to be doing. So I do want to see, you know, what function it's going to serve in your machine, just because that's helpful for, you know, having a big picture of what's going on. And then toward the end, you know, you'll want to be able to look back and say like, you know, I printed this part to do this and this part to do this, and that's all in your write-ups. Um, and then, so in your introduction, just say like, this is what the part is, and this is what I'm printing. And then in materials, try to put, just put, this is, you know, this is how much of the 3D printer material I'm going to use. So in your software here, it'll show you, um, how many grams. This is 36 grams right here. So put that in there. And then also your time. So I know under materials, like the time is kind of weird, but that's the best spot to put it. Just put, this is going to take 2 hours and, or 3 hours and 36 grams. Um, and then in your next section, I just want you to lay out kind of what your part is, give me a picture of it, and what it's going to do in your machine, why you're printing it versus acquiring it some other way. And that's pretty much it. But I want you all to stick to that format because it makes it a lot easier for you when you're looking back. Everything's formatted the same and you can see like what your plan was from start to finish. Does that kind of make sense? Cool. All right. So, um, I think that's unless anyone has questions, that's all I had to really say on that subject. Mhm. Yeah. Mhm. No more. No, I think, if you can justify 8 hours, then 8 hours is reasonable. I think what I want to see is like that, the justification for the 8 hours. Like say, okay, I put it into Cura, I I turned the infill down as much as I was comfortable. Like I'm gonna have 30% infill. If there's any less than that, I'm afraid it'll be too weak. So that's what I'm gonna go with, and it's still, you know, 7.5 hours or whatever. And then and then I'll look at that and I'll say, okay, that makes sense. Um, and go ahead and print it that way. I think, and I think that's reasonable. It's like one of those, we can probably start the print at the end of the day. When you come back in the morning, it'll be ready for you. So it's fine. 8 hours is fine. I don't want every single part to take that long, but you did say like this is going to be your biggest part. And you want to get it out of the way first. And I think that's reasonable. I think that makes sense. So, um, if like every single thing that you go to print is going to be 12 hours or more, I'm going to be like, okay, calm down. But yeah, I think that'll be fine. I think, I want to see like, play around with it in Cura a little bit and change some parameters. Okay, cool. Yeah. Yeah, you can as long as they fit on the printer. It'll also like double your time, so if you're printing one part next to another part, it's still going to take the amount of time that it would take to print them one after the other, pretty much. But my water bottle kind of squeaks, so if I take a sip of water and you hear like a weird chirping noise, that's my water bottle. um, all right. Any other questions? No. All right. Cool. So let's move on to printing some or printing, drawing some threads. Let's see if I can open some stuff over here. I had a couple of parts open, so I'm just going to close everything. Why isn't that? Okay. I might just need to close everything. Okay, so I did this the other day. This is basically a piece of all thread, I guess you could call it. Actually, that's not the one I did. That's another one. I did this one. So, basically also a piece of all thread. But I'm trying to get it in the middle here. Okay, so the way you do threads is basically um, you start with the piece you want to put threads on, right? So usually it's cylindrical or it's got a hole through it, and then you do a helix, a helical line around it, which you can see when I hover over this. Um, and then you actually make a plane at the end of your helix and you sketch a cross section of the thread onto that plane. So let's go through it real quick. I'll just start a new part here. Close out of these guys. Um, it comes back once you work with it a little bit. So so we're gonna do a new sketch. We're gonna start on the front plane. Just start nice and simple here. We're just gonna draw a circle. And we're going to extrude our circle. Just give it a dimension real quick so that we have that. Just make sure everything's fully defined. Actually, before we do that, let's put it in IPS so that I kind of know what I'm working with here. And let's make this 1 inch in diameter. Alright, so we've got a pretty big screw here. It's 1 inch in diameter. We're going to go ahead and extrude it. We're going to make it a big bolt. It's going to be, let's see, let's do 10 inches long. Let's change the direction. Alright, so I've got a bolt here. It doesn't have any threads on it yet. So, let's see, the next step here, so we're going to go back into our sketch. Let's see, where was this? This was in, actually, I think this was in features. So we gotta exit the sketch. Sorry, I did this like a week ago. Alright, yeah, here it is. Okay, so under curves, under features, go to curves, and then the bottom one is helix and spiral. So we're going to select a plane on which to sketch a circle to define the helix cross section, or a sketch that contains a single circle. So we're going to use that first sketch we did. We're going to use that circle. Actually, I think if I just click on the circle, that might be the way to do it. For some reason, it's making it kind of hard for me. Okay, so if you go into your features tab under curves here, it's the last one. I got into a sketch here, so let me exit that. Yeah, so right at the bottom there. Okay, so I think I need to start over. Okay. So in sketch 3, we're gonna, basically so when you do your helix, it says select a plane or a planar face on which to start your helix, basically. So I selected this front face of this bolt. That's where we want our threads to start. And so it creates a new sketch for you. In that sketch, you're going to go ahead and you're going to draw the same circle again. And I'm going to click OK. I'm going to give it a dimension because, again, you just want things fully defined. Because why not? It's going to be 1 inch, even though we already kind of made it the same as the other one. Click OK. And alright, why isn't it showing up yet? There we go. So then you actually have to go back. You have your circle, you have to go back and make your helix. So we want it to, let's see. We want it to be the length of our actual bolt, right? We don't want our threads to keep going. So you can change the pitch of your threads. So like, I don't know how much experience you all have with like I think you covered this a little bit in FSME, but like different bolt sizes and thread pitches. So like say you have a 5 millimeter by 0.75. The 0.75 is going to be the thread pitch, or like the distance between from one thread to the next. So I only went into metric there because at my job we use all metric bolts, and like that was something that was just the example that popped into my head. But um, so for since we're doing this in inches, that's the units that I just chose. Let's see. We've got a 1 inch bolt. Let's make the thread pitch like, what would be a good thread pitch for a 1 inch bolt? I can't remember what the standard is because I don't usually use um uh British or standard, or not, what is it, inches. um let's go ahead and do like point 0.2 for the pitch. That looks reasonable, right? So it's about 2/10 of an inch from each thread to the next thread. And then 50 revolutions is going to be exactly the right length for a 10-inch long bolt. So, yeah, I think that math works out. So we've got 10 inches. We've got 5 threads per inch, since the threads are 2/10 of an inch apart, or 1/5 of an inch apart. We've got 5 threads per inch times 10 inches is going to be 50 revolutions, 50 threads. So, cool. All right. Let's click OK. Now we've got a helix going all the way down here. So, cool, we have a spiral. How do we turn that into threads, right? So let's zoom in and find the end of our helix here. So this is the kind of tricky part, is you got to find the end of that helix. And there it is, you can see right here. So now we're going to do reference geometry. We're going to make a new plane at the end of that helix so we can sketch a cross section of one of our threads on the plane. So go into reference geometry, you're going to make a new plane, and your first reference is going to be not edge 1. You're going to pick the end point of your helix. So you see that little tiny orange dot? That's going to be, shoot, I didn't actually click on it. So you got to very carefully get in there and click on that little orange dot. Cool. And it should be 0.1 or point something, depending on your sketch. So now if you kind of rotate it around, you can see this plane is facing the wrong way. You don't want it this way. So your second reference, I'm sorry? What was that? Yeah, you want it like perpendicular to this face. So I'm gonna go like that. I think that's perpendicular. I feel like it's still pointing the wrong way. The first time I did this, it just automatically went right where I wanted it to, and it was super easy. So 0.1, we don't want coincidence. Let's try. No, that's not gonna work. It's supposed to be splitting right down the middle of your bolt. So, let's see. Let's see here. I'm trying to. So we want it like perpendicular to this. Because you want it like, so you want it where that point is, you want it to be exactly perpendicular to the thread. Oh, you know what? I think it's my second reference. I think I need to select the actual helix, and I think I need to make it I think I need to make it perpendicular to the helix. Did that do it? Yes, that did it. Okay, so you want it to look like this. You want it to go right through the middle of your bolt. You want it to be perpendicular to that starting point on the helix there. So when you zoom in, click OK. Yeah. Okay. Yeah. So when you Mhm. Yeah. Okay. It's fine if like this box is small. That doesn't really matter. You can actually drag that to make it bigger or smaller. Make mine a little smaller so it's easier to work with here. But um, the point is it should be going like it should be cutting right through like this. It should be perpendicular to the starting point on your helix. So, all right, we're gonna go normal to this. Oops, we don't want to edit. We want to go normal to this plane. And we're going to sketch a cross section of our thread right at the end of that helix. So the thing that's hard about threads for me is always like just how hard it is to see what I'm doing. So we want to go to our end point here. But let's try making like some pointy threads. So let's do a line. So this is going to be the center of our shape here, I think. So we're going to start here. We're going to go out here. We're going to go up here. We're going to make a little box like that. All right. I think we want to make it a little bit bigger. So let's dimension it. Let's do 0.15 and 0.15. And let's add some relations. So we'll make these guys parallel. Oh, that guy. Shoot. Oh, I just deleted a dimension somehow. Yeah, it's tricky. So I think what you need to do is make it perpendicular to the helix. That's the really important part. And then you need to make it coincident with the end of the helix. If it doesn't look like mine, but you have those two things set in stone and you know that they're right, then I think you'll be okay. I'm just trying to add some relations here and it's like acting weird on me. Like I'm just trying to click these lines here, man. All right. Those are parallel. And we'll add another. Make those guys parallel. And also equal. Um, do one more. Is equal. All right. Make this horizontal, and then last relation. I'm just trying to get this fully defined so that it works. 1 second. So there's easier way to do this. easier ways to do this. Shoot. um, I just figured I would make pointy threads here that look like threads. Um, when I tried it before, I just did it with like a rectangle, which was way easier. So I don't know, but oh, yeah. So all right, add one more relation. I'm gonna click that point and that point. Make them vertical. There we go. Now I think it's fully defined. Okay. Yeah. All right. So once you have your shape on your plane here, you have a cross. This is a cross section of one thread. So then we're gonna go back to features and we're gonna do revolved thing. So axis of revolution. Shoot, is that right? No, it wasn't a revolve. It was a sweep. So X out of here. That's right. We're gonna sweep it. So the profile is gonna be your new sketch here, and the path is gonna be your helix. So there you go. There's some threads. Once you do that, they'll show up, and then click OK. And there's some threads. Mm-hmm. Yeah. So yeah, and if you like there I mean there's different ways to do it. Yeah, if you want to make it a channel, you could do a revolved cut instead of or a swept cut instead of a swept boss base. Just do swept cut, which is right over here. It basically does the opposite of what I just did. So let's do this. Let's do a new configuration here. Um let's call it I'll just call it swept cut. Alright, and in this configuration, we're going to go back. Make sure we're in that one. So I'm going to delete the sweep here. And we're going to try doing a swept cut. So the profile is going to be sketch 4, and the path is going to be your helix. And it should have cut out the threads instead of adding them in. So it looks like it did it kind of weird. I'm not sure if that worked. Are they on the inside? I think, yeah, I think it like put them on the inside, kind of. I'm not really. What's that? Yeah, I'm not really sure what happened there. I just did like a swept cut. I think it put them like on the inside or something. But yeah. But I would say like just do the swept boss base. Um if you want to make it like a little smaller, then start with a smaller cylinder. Let's try let's delete this since we're in a configuration here. Actually, let's just do a new configuration. And let's call this square threads. Okay. So if we go back here, let's delete sketch 4. Actually, let's make sure this is what we want to delete. Yeah, that's our little diamonds there. So let's delete sketch 4. And let's do a new sketch on plane 4. On plane 4, do a sketch. And let's just do a little square. So let's do a center rectangle. And our center is going to be that end point there. Go like that. Okay. Smart dimension. We'll go 0.2. Actually, let's do this 0.1 because 0.2 might be too big. And 0.1. Alright. Now let's go over to our features and we'll do a swept boss base, and the profile is sketch 4, the path is going to be our helix. So now you've got some square threads here. Yeah. Mhm. So, yeah, so actually that's what I just did. The threads sink into it a little bit is what you're seeing, I think. But that square, if you look, I have my cylinder here. Let's do this. Let's go to sketch 4 so we can see what we're looking at. Um, so I drew this rectangle on the edge of that cylinder, right? But it overlaps it a little, so the threads don't stick out a whole tenth of an inch, which is the size of like the square on a side. Um, but yeah, they do. This does come out from here. Let's delete this sweep and let's try doing a swept cut. So that would cut into, that's what I just tried to do, but it didn't work for some reason. That would cut into your shape. So yeah, so this one I did. I just did a swept cut. So it worked with the square threads. But the first one I did a swept boss base. So it's like, this is like an extrude. This is like an extruded cut, the swept cut. So that cut the threads in. Um, so I guess another way to explain it, if you look at this, the outer diameter here is going to be the outer diameter of my original cylinder. If instead of doing a swept cut, I were to do a swept boss base, then the outer diameter would get bigger because I would be extruding those threads around instead of cutting them out. Hmm. Yeah. Yeah, so it's kind of tricky making sure that your threads are actually going to match up. I would, if you're doing threads, and you're 3D printing if you're 3D printing like two parts that thread together, I would definitely print them really small and test them first. Unless they're small parts to begin with, if it's going to take less than an hour, like go for it. But I would, if you're not sure and it's going to take a few hours, I would print them really small. Make sure that the threads match up, and then keep those proportions the same. So the two parts that thread together, keep them the same in relation to each other when you make them full size. So like you could quadruple the size of both, for instance. Um, mhm. Yeah, and actually you can do that in Cura. I think if you do the scale thing here, um, so you could change the percent. Yeah. So like just make X, Y, and Z all 25%. And it should automatically do all three. And then do the other one the same percent. And then if they work, then just put them all at 100%. Does that make sense? Oh, are you seeing it on mine too? You can see like the lines there. Oh, let's see. I'm not sure. Oops. I just uh I just messed mine up. um. All right. I just did an undo. I didn't mean to do that. So let's just go back to my old configuration here. No. Come on. Okay. I hid some stuff somehow. Oh boy. Um. Anyway, yeah. No, I think. Let's see. I'm trying to remember how to get rid of those lines, but dang it. There's here. If we go back to your helix, we can maybe suppress it. Okay. Somehow I just deleted all my threads though. That's the only thing that is kind of annoying. Yeah, I think if you suppress your helix, it suppresses everything that is built off of it. I'm not sure. Yeah. That's what I was just trying to do. Yeah, I think you can, but I can't remember. Can't remember how. This is annoying because I just had like um I had my dang it. I had my thing like all done here and it just disappeared. So I'm gonna do this. Yeah. Like, oh no. Alright. Let's just put it back. There we go. So there's my threads. They're back. Um yeah. Uh how to hide those lines. It's not in there. There's like an actual way to just hide outlines and I know what it is. I just can't remember how to do it right now. Uh oh. Yeah. Mhm. Oh, okay. In your is it like over in here? Somewhere in here? Back here? These guys? Right here? Yeah. Okay. Somewhere in here. import scheme. Here? I am all the way to the left. That's the part icon. Hmm. So I've got part 2 here. Yeah, I'm not seeing it on here, but no, I don't think so. Hmm. Shoot. Well, huh. Interesting. Maybe because there's not really much of a history to show. I don't know. That's weird. Um, anyway, getting back to the threads here, there's a couple other cool features that you can do. So, if we go into our sweep here, you can edit this and you can change a couple of things. So see how, like, for instance, the threads stick out past the end of the bolt? So you can do this start and end tangency, and you can put path tangent. And so one of these is the front end, one is the back end. I'm not sure which is which on my part in particular. Um, let's see what else is in here. And I think you have to check align with end faces. Okay, yeah, that's the it's not the tangency thing. So if you do align with end faces, then your threads will actually end at the end of your bolt. So see how now that end is flat? I don't know if you can really see that. Yeah, so if you go in sweep, if you click on sweep and then you go right up here to edit feature, and you go to options here, and just click the little drop down, and then check this align with end faces box here. So if I uncheck it, you can see these. Yeah, or like you have to start your helix a little bit offset from the end of your cylinder. Yeah, so this makes it just flat at the end. It just cuts it right off, so that's kind of helpful. I have like this pink spiral thing going on here now. Yeah. I don't know what's going on here. Let's see what happens. Nope, nothing. Or like orange and pink and really making my eyes hurt. Let's see if I can, I can't remember how to hide this stuff. I know there's a really easy way to do it. Um, hmm. Well, I'll figure it out and then I'll let you guys know. But I really want to figure it out right now. Did this hide show? Ooh. Okay, so if you go into view and then hide slash show down here in the middle, um, it'll show everything that's gray on the side here. So just click it to hide it. So let's I'm just gonna hide a bunch of stuff. Um, just see if I can get that pink line to go away. Hmm. Interesting. I know I had somebody last quarter who like had his dimensions, all of his dimensions on every sketch showing up all the time, and it was because he had something in here selected that didn't need to be selected. Um, yeah. Mhm. Hmm. Yeah, so if you go into a sketch, you should always be able to see the dimensions once you're in there. But if you want to be able to see everything, so let's go back in here. If you want to be able to see all your dimensions from right here, I think you want to show sketch dimensions and you want to show all your sketches. Is that, I think my sketches are also fairly small, so I'm not sure if that worked, but I turn on all annotations. I still don't see them, but hang on. Sorry, just sneezed. Thanks. Mhm. Oh yeah. Mhm. Yeah. Yeah, that's I feel like that's something that it kind of depends on how the software is interacting with your computer. Like if you don't have a lot of disk space, this program takes up a lot. So uh if you're using too much, it'll start acting kind of funky. Um yeah, I don't know. It's tricky and like getting it it's supposed to like automatically kind of optimize for, obviously like your screen size and everything. But I think SolidWorks tends to be a little bit more buggy than like your typical like open source software that you would normally use. It's a big clunky program and it's got a lot going on. So I think like everybody I know that's used it is like, oh yeah, I run into these weird problems sometimes, and I don't know why it did that, but or like it just did this weird one thing once. Like I don't know why I have this pink spiral on on my screen right now because it never really does that, but it's doing it for some reason. Yeah, and then I tried to like get rid of it, and it made it worse. Yeah. Oh man. The Helix virus. Oh jeez. Yeah. So, all right, let's try another thing here. I'm gonna do a new sketch. So there's one other thing. And we'll be quick with this. Oh, brother. Yeah. See, I get that little error message every time. I don't know why it does that. Um, it just does it. It doesn't actually mean anything, so I ignore it. But all right. So let's do a new sketch. Front plane. Let's just make a box. I didn't want the center rectangle. Let's do a corner rectangle. Just make a big box here. Okay, dimensions. Let's change this to inches again. Mhm. Yeah. Okay. Yeah. So the way that I would do it is I would stand it on its end, like I would print it like this. Yeah. Um, and depending on how big your threads are, it might do little supports in between all the threads, but you can just cut those out with like a razor blade or, pocket knife or something. You can just chop off all the little supports afterwards. Um, like a foot ish, I think. Okay, so not quite as tall as it is wide. Um, yeah, so I would try to keep it under like anything you do under like 8 inches tall, just to be on the safe side, probably, because um, yeah, you could do that. It might be a little tricky getting all your threads to line up right, but you could probably do it. Um, yeah, I would even like maybe have the end faces like snap together somehow. Hmm. Um, I would. I think you can do segments in SolidWorks. Yeah, you can sketch pieces. So like say I wanted to do this, like I could just do like uh well, I would just like copy it and print several. Yeah. Yeah, like you could do like a little indentation in one and then like have a little shoulder on the other one so they fit together. Um yeah. Yeah, and you can line up your threads manually afterwards cuz you just have to make sure you like make the ends flat like I just showed you. That's kind of the important part there. So, um but yeah, as long as the ends of your thing are flat and like your threads are, end at the end of your cylinder, they don't extend beyond it. You should have no problem just kind of attaching them together. Because it's going to be it's a helix. It's going to be the same thread pitch and everything. So they'll always line up at some point. Does that make sense? Mm-hmm. Yeah, yeah, because it could be like the wrong. I don't know. I think you could still line it up if it was a square. I don't know. That's a geometry problem. I'm not a mathematician, so no. I think you could make it work though. So, all right. So the next thing I want to show you actually is how to do inside threads. So like we just um we just made a bolt. Now we're gonna like make a hole that's tapped to thread the bolt into. Um, oops. Where's my where's my other part here? Dang it. Let's close this one. I'll save this as... Oh no, SolidWorks is... expires in 10 days. I'll have to figure that out. Alright. So we got our rectangle here. Let's, we need this inches. So let's make it... Oh my gosh, I just want to edit this sketch. Alright, let's make this dimension, let's make it 24. We'll make it 2 feet by 2 feet. Okay. And then let's try and put this origin right in the middle. So we'll do 12 and 12. Okay. And then we'll extrude this. I'm going to do 24 the other way. There we go. Alright, so we have a cube. So let's drill a hole in our cube here. I'm going to sketch on this front face, I guess. I'll just make a circle right here. And I'll make that... I'll just make it 1 inch in diameter again. And let's put it 6 inches from this side and do 8 inches from that side. Okay. And then extruded cut. Direction is through all. Alright, so now we've got this hole in our block here. So we're going to basically do the same thing. We're going to use this circle in sketch 2, actually. And we're going to go to features, and we're going to do a helix. Oh. Let's just... Okay. Let's just put it on this face, and we'll do a new circle. I haven't figured out how to use an existing circle yet. Oops. Other than to just draw a new one on top of it, which is annoying, but... Alright. Click OK. And then we gotta go back and do our helix, I think. So let's make the pitch the same. Let's make it 0.2, 50 revolutions. Oh, you know what? We did 24 inches instead of 10 inches. So if we want it threaded all the way down, we have to do 100 and... shoot. 120 revolutions, is that right? Let's try it. I'm not good at math in my head, really. Okay, yep, that looks right. Cool. So now it's threaded all the way down. So now we're going to do the same thing here. We're going to just draw, we're going to make a plane on our end of our helix here. So first reference is going to be that end point, if we can find it, right here. Going to be coincident with that. The second reference is going to be the actual helix, and it's going to be perpendicular to that. And then on that plane, we're going to sketch, let's just do a rectangle again. Just do a little baby rectangle down here. Okay, let's go my gosh. It's like just really hard to see what you're doing in here. It's frustrating. But let's give this some dimensions. Let's say 0.1 by, and notice I'm kind of making all my dimensions the same, so hopefully this would line up with the bolt that we made. Let's do another dimension. Let's go from here to, can we go to the origin? This is kind of hard. Never mind. Alright. Let's just try and like drag this over so that it, huh. Just trying to think of how to, I'll try adding a relation here. So we'll do line 1, line 2, and then we'll put this here. Oh shoot, I was hoping I could make that the midpoint, but I can't. I just want to select this point as the thing, and there's like not really a point there. Let's try. I'm not sure. Let's just not bother trying to fully define it right now, just so I can show you how to do this. Alright, so then we're gonna go, let's do a swept cut for this one. So the profile is sketch 4 and the path will be our helix. It's thinking. Click OK. And we should have a threaded hole in our block here now. Let's see if we can. And of course, another thing you can always do, oops. Another thing you can always do is use the hole wizard feature to make threaded holes. That's an option. This is just, you know, if you want to do it a certain way, like make the threads a certain shape or line it up with another set of threads you already made. But as you can see, we have threads in this hole now. It's kind of hard to actually see them. But there you go. Any questions? Y'all still with me? Okay. Yeah. I mean, it's the same exact technique pretty much as what we just did with the cylinder to make the bolt. You're just kind of doing it in reverse to make it a hole in a part that you have. So the other thing, like I said, you can do hole wizard. It's a lot easier. So if you do this, you can do like a different, you know, you can do all different types of holes. You can make the size a certain thing. You can do a countersink or a counterbore. And you can select different types of fasteners that you want going into the hole. So, and we went over Hole Wizard a little bit last quarter. Hopefully, I think most of you probably covered it in CAD 1 when you took it. No? Oh, okay. Well, all right. Well, I guess maybe we should then. It's not. Here's the thing with Hole Wizard is it's useful if you're designing something where you need to have different kinds of holes that are like threaded and tapped and stuff. It's not something that's going to come up on this certification, the CSWA or whatever. It's not going to come up on that. You're not going to have to use Hole Wizard stuff on there. So it's kind of one of those like if you need to know how to use it, then you need to know how to use it. For the purpose of this class, you don't necessarily need to. I'm gonna go over it, I think maybe not today, but I'll go over it just because it's important to cover, I think. I know, like, for me, at the company where I work, we have mechanical engineers who do all of our mechanical drawings, and, like, I'm not a mechanical engineer, so it's not really my domain, but I do inspect a lot of parts, and I do put a lot of assemblies together, so I use their drawings every single time I do anything. And like everything we make has threaded and tapped holes in it, and everything that we build uses fasteners of different sizes and specifications. And so if you are doing like mechanical drawings for pretty much anything, you're gonna need to know how to use this stuff. So that's why I think it's important. Because that's my experience. Everybody's background is different, obviously, and like there's gonna be some people who are like, "Oh, I used SolidWorks for 20 years and I never touched Whole Wizard," or something. I don't know, but um, yeah, there's gonna be features I never get to in here, and like there's a million features. Like you're never gonna use everything that SolidWorks has. So I think that's kind of the thing is like on the one hand, I might cover different things than what Jason covered or vice versa, but in the space of 2 quarters, like you're literally getting like an intro to, how to use this stuff. There's so much to it. So, I don't know if that helps, but just my thoughts on the matter. Um so, does anyone have any questions about threads or any of that stuff right now? Should we keep going over anything or Yeah, and we're not going to go over that today, but we will go over it. It's just kind of a lot to get into right now. So I'm going to dedicate a class to doing those too. Um, so it's a lot of like circular patterns, basically, is what it comes down to. But more or less, yeah, we'll go over it. It's kind of a lot to explain, but yeah. Yeah, like I mean you can scale stuff in SolidWorks. You can use tables to, make your sprockets scaled to each other. So I'm not sure if there's a function specifically to scale sprockets in particular, but there are scaling functions and ways to scale things to each other so that they will match up. So we'll go over that stuff. Any other questions? So the profile is going to be your sketch of the cross section that you did on that plane you made. So I have this plane 4, that's the plane that I created. Um, that's the one that has the sketch on it. So let's see, it shows up under my sweep once I've made the sweep. But you're going to use that sketch that's on that plane. And then for your path, you're going to click this helix here. So you can actually select it over here in your feature manager tree thing here. You can just select the helix, or you can click on the line that is the helix. But that's your path. Does that make sense? What's it not letting you do? Mm-hmm. Hmm. That's weird. Um, so try here, I'm just gonna you got it? Okay, cool. Yeah. So see my my tree over here? Instead of trying to click tiny little stuff in here, it's easier. So for your profile, that's the first box, just click sketch 4 right here. Do you see that on the side? And then for the path, just click helix right here. So you don't have to like zoom in on here and try and find the stuff. Does that help? Yeah. Mhm. Yeah. Yeah, I mean you can, you can use whatever units and shapes you want as long as you get the general principle. So, but yeah, it's tricky cuz like with this helix stuff, the scale that you're doing things on is so wonky because you have like this big part, right? And then you have this little hole in it, and then you have this teeny tiny little sketch on that on like the edge of the hole. So there's a lot of like zooming in and out to try and see stuff. It's annoying, but mhm. Cool. All right. Any other questions? Everyone good? All right. I think I'm gonna close for today. So next week it's gonna be the same thing. Keep in mind what I said, and actually I might post a template for like your justification, just so you have something to kind of go off of, like just fill in the blanks. So I'll just put like put your yeah. Yeah. All right. So weeks 1 and 2 are due tonight at midnight. So you've got two parts due tonight. And hopefully we can start printing those ASAP. I'm gonna go over your stuff tonight, so I'll try and start printing stuff on Wednesday. I also want to get with Jason, and hopefully I can print like 2 or 3 things on Wednesday and not just one. But regardless, I'll start printing stuff. I'll get through as much as I can while I'm here in the lab on Wednesday. And I'll try to swing by on Thursday and maybe do a little bit more. But mhm. Yeah, absolutely. You just need to get the go ahead from me, and I'll give you that once I look at your assignment and give you a grade. So, yeah. No, I want to look over everything first, real quick. Sorry, it won't take long. I'll have like if you've got stuff turned in today, I'll have it ready. I'll have it graded by the end of tonight. How's that sound? Okay. Yeah, no. I mean, and I definitely want to start getting stuff printed. Like we're 3 weeks into the quarter now, which it's flying. So yeah, so I want to start getting your projects underway so we actually have a machine at the end of the quarter. How's everybody's teams going? Have you all figured out your handoffs and stuff like that? Okay. All right. I guess hopefully you should each have like sort of a cohesive machine of your own. So if you can line them all up and make them work together, then so much the better. But if you can't, like, if it's hard to coordinate, I'm not gonna take points for that or anything. I know like with COVID and stuff, like, and people, and the restrictions on campus, it's just really hard to meet. So I totally am not gonna. I'm gonna try and go easy on you there. Um, Cool. All right. Sounds good. All right. Okay, so you should have two parts turned in tonight by midnight. Try and make sure you have that software so you can give me your material uh, usage and print time. If you already turned it in and you don't have that in there, if you just want to like shoot me a quick message and just say, yeah, my print time is going to be this or whatever, then that works. That's totally cool. Um, and I'll try and get those graded as soon as possible and print stuff Wednesday. And then next week, same time, same place for class. And then by midnight next week, you'll have your week 3 part turned in, or your part number 3, I guess, however you want to say it. Does that make sense to everyone? Cool. All right, and I'll post on Canvas, like right on the home page. I'll try and post like a template for your justification. So, let's see. Let me go to the home page here if I'm even still logged into Canvas. Oh boy, it's really slow right now. Yeah, I am. Yeah, absolutely. Let me I'm not sure if my headset will work if I'm what the Okay. Yeah, I'm not sure what my range is on this headset, so if I cut out for a second, I'll just walk over there real quick and look though. Can you guys still hear me or did I get too far away? You can hear me? Alright. So the sticker on here, it's a Lulzbot Taz Workhorse. The serial number is KT dash. I don't know if anyone's writing this down. Might be helpful. Um, okay. Actually, you know what? Someone left a pen sitting here, and it looks like the end is all chewed up, so I'm not going to use that. Jeez. Um, Here's a pencil. I don't know whose it is, but I'm borrowing it. So it's a KT dash PR0051NA dash 1489. I'm gonna write that down too, and I'll like send you all a message. But. Mhm. And then dash 1489. Um I'll just I'm writing it down too, so I'll just send you guys a message with the. This is just a serial number, so I don't know how much information you'll get from it, but yeah, I'll do that. Um, yeah. Yeah, Jason said it's basically the same, and if you put that in the software, it'll still work. So I don't know. I mean, I just was like, I'll take your word for it, but yeah, might be good to have the right stuff just in case. And then it looks like there's no measurement on this surface. It's got like little grid lines. I don't know. I just turned it on and it's moving. Um, so it looks like it's about a foot Yeah. It's about a foot by a foot square, and the head of the printer is like a foot above it, but it probably can't. I don't know how high it can actually go. Like print wise, I don't know how much it can. I don't know how high up it can print, like how high it can stack the printing material. I don't know if that makes sense, but yeah. And I think if you have like you have the info here, I'll just look up the actual specs because it doesn't say on here like print area 1 foot by whatever. So I'll just look it up. But yeah, I'll put all this stuff into the template thing, so don't worry about writing it down if you didn't catch it. Let me walk back to my computer here real quick. And we have 3 of that exact printer. I don't know which ones work or don't. I'm pretty sure the one I just was looking at works. Like it's hooked up to a computer and ready to go. The other 2 I'm not sure about. I think I tried to like connect to one of them and I couldn't the other day. So I don't know if um that's actually yeah, I mean I don't have $3,000 lying around, but um if I did I might buy one. Alright, so I don't know if you can see my screen here. I'm gonna put the template right on this home page. I'll just put a link down here. Template for justifications or whatever. Hmm. Hmm. Interesting. Is that bigger one the height? I'm guessing. So that would be like your uh y axis. Yeah. Yeah. All right, cool. Okay, I'll type this up and I'll post it tonight and I'll get you guys your stuff graded so you can start printing. So I'm gonna let you all go unless you have any other questions. No? All right. Yeah, I was. Okay. All right, everyone else have a good night and talk to you soon. Hopefully Wednesday or if not sooner than next week.